and welcome to all of you in Wings classes with Vinay. Today I will explain you about the refrigeration table. This one is a refrigeration table which I am using to explain you. Previous video is based on the pH chart and TS chart. The TS chart which is most useful in academic point of view, and this one is a pH chart. I will explain you the pH chart and refrigeration table in this one. Then I will explain you about vapor compression refrigeration system, which is the most important part of refrigeration system. So this is a refrigeration table, and in this there are hydrocarbons, there are halocarbons, inorganic refrigerants, hydrocarbon refrigerants, cryogen absorption fluid solutions, in which the refrigeration table there are some designation. It is R12, this is R12, R22, R23, R32. These are the designation of refrigerant. These are halocarbons, and the inorganic refrigerants are R717 ammonia, R718 is water, R744 is carbon dioxide. These are inorganic refrigerants. Similarly, R50, R170, R290, there are hydrocarbons. Some refrigerants are also available. R134A, these are cryogenic fluids which we are using: oxygen, argon, air, nitrogen, helium. All these are refrigerants. I will explain you a single refrigerant with pH chart. I'm taking the example of, this is R12. I'm taking the example of R12, then R22. I will explain you I already explained you the TS diagram. Now I am explaining you the PS diagram of R12. So I will start with, this is a diagram for R12. This is the refrigerant which is used is R12. This is a dichloro-difluoromethane, R12. The designation of refrigerant is R12. This is the pH chart for R12. This one is a pressure on y-axis and enthalpy on x-axis. That's mean P for pressure, H for enthalpy. This is pH diagram. So, and next there are some values of enthalpy values, and in this chart there is a critical point. I will explain you about this one. And this one is a critical point. This is a critical point. That is denoted by CP. From the critical point, the left side line is saturated liquid line, and rightward line is, this one is saturated vapor line, and some other lines are also there. These are dryness friction line. I already explained you. These are dryness friction lines. Is it clear? These are dryness frictions which arise from the critical point. This one is saturated liquid line, this one is a saturated line, and these are dryness friction line. If you I will explain you about, this is dryness friction point 1, this is dryness friction point 2, this is dryness friction point 2, point 3, this is dryness friction point 3, x is equal to 0.4, this is point. At this line the dryness friction is 0. At this line the dryness friction value is 1. There is continuously increase in dryness friction point 1, point 2, point 3, point 4, point 5. That's mean 10% vapors are produced, 20%, 30%. At this point all the molecules are in liquid state. At this point all the molecules are in vapor state. So if you are moving through this, that's mean there is increase in amount of vapor. There is increase in amount of vapor. So these are dryness friction line. I explained you about the dryness friction line, and this is dryness friction. These are dryness friction line, and in this chart the most important is a temperature line. If we follow, this is a 0 degree Celsius line. This is a 0 degree Celsius line. If we follow this 0 degree Celsius, this is moving in downward direction. This one again is 0 degree Celsius. That's mean if we are following on this side, this is a 0 degree Celsius line. That's mean the temperature, the constant temperature line in this chart, this is a constant temperature line. This is moving like this. in diagram. If I will follow 20 degrees Celsius, that's mean there is a 20 degrees Celsius. This is one is Celsius. This is saturated region. After this, in superheated region, if we are moving downward, this is again 20 degrees Celsius. If we are moving in liquid region, this is 20 degrees Celsius. That's mean this is a constant temperature line. This is a constant temperature line, 20 degrees Celsius. Similarly, this is a 40 degrees Celsius line. This one is a 40 degrees Celsius line. These lines are constant temperature lines. These all are constant temperature lines. So these are constant temperature line. I explain you about the dryness. This is a critical point. This one critical point. Saturated liquid, saturated vapor. All these are dryness fraction lines. This is a constant temperature, 3 degrees Celsius. This is a constant temperature line. All these are constant temperature line. If I will explain you about the entropy line, look at this one, these lines. These are constant entropy lines. These are constant entropy line. 1.95, 1.90, 0.85, 1.80. All these lines are a constant entropy line. Entropy is constant at these lines. These lines are constant. These are constant entropy line. So I am again explaining you all the parts. This is a constant pressure. I am using the red color. This is a constant pressure. If we are, these are the constant pressure line. This one is a constant pressure line. If we are, this is a constant pressure line. This is again a constant pressure line. If we are taking 2 bar, this is 2 bar. This is a constant pressure line. After this, I will explain you the temperature line. If we are taking 0 degrees Celsius, if we are taking 0 degrees Celsius, this is 0 degrees Celsius line. We are moving downward. This is 0 degrees Celsius. These are the temperature line. This is the critical point. This is saturated liquid vapor line. This one is superheated region. This one is liquid region. In between this is wet region or a latent heat of vaporization region. Latent heat region. So and after this, these lines are I am using the color change to easily explain. These lines are isentropic lines. Entropic. These are isentropic. Yellow lines are showing the isentropic lines. This is the pH chart, which is most important. We directly calculate the result through this chart. This one, if I explain you, this is superheated region, this is liquid region, and this one is a wet region. This is liquid region, liquid, vapor, superheated region. After this, at a particular point, I want to calculate if I am using this point. If this is a point, we have to calculate temperature, we have to calculate entropy, we have to calculate enthalpy, dryness fraction, pressure at particular this point. So what is the temperature at this point? We have to follow these lines. At 30 degrees Celsius at this point, that means 30 degrees Celsius is the temperature. What is the value of entropy? We have to follow the dotted lines. These dotted lines. That means 1.45 is the entropy at this point. What is the value of enthalpy? We have to follow the straight vertical lines. This is the enthalpy at particular point. Point number 1. This is point number 1. At point number 1, we have to find out the enthalpy. This is the value of enthalpy. This is the value of entropy. This is the value of temperature. We have to calculate the dryness fraction. These are the lines of dryness fraction. So at this point, the dryness fraction is around 0.8. We have calculated the dryness fraction at this point. If we want to find out the pressure, we have to move this line. 0.6 bar is the pressure at this point. So we will calculate all the parameters: temperature, entropy, enthalpy, dryness fraction, pressure with respect to this. After this, I want to take the another point in superheated region. If we're taking this region, this is the point number 2. I have to calculate all the parameters with respect to this one, the temperature, entropy, enthalpy, dryness fraction, pressure. At this point, the dryness fraction value is 1 because all the molecules are in form of, so in this region I remove the dryness fraction point because it is in superheated region. So at this point, what is the value of pressure? We have to move like this one. This is the pressure value. This is the pressure at point number 2. This is P2. And what is the value of entropy at this point? We have to follow these lines. This line. This is 0.70, 0.75. In between this, there is an entropy. We will easily calculate by measuring the this value. The most important parameter is temperature. How can I find out the temperature at this point? We have to follow these curve lines. These curve lines. These curve lines are moving downward. This is 60 and then 70. It is in between 60 and 70. This is 60. Again, this is 60 temperature. This one is a constant temperature line. This is a constant temperature line, and point is nearly about this one, 60 and 70. This is in between 60 and 70. The temperature is in between 60 and 70, 65, around 65. So I calculated the temperature, I calculated the pressure, I calculated the entropy. Now I have to calculate the enthalpy vertically downward. From this point, we have to move vertically downward around 400 degrees Celsius, a little bit less than 400 degrees Celsius, 400 kilojoule per kg. The unit is kilojoule per kg. That's mean at this point, point number 2, the enthalpy is around 400 kilojoule per kg. So I calculate all the parameter with respect to a single point through this chart. I directly get the result through pH chart. This is the most important. So thank you very much. This is the refrigeration table for refrigerant R12. This is R12 refrigerant which we are using. In this, taking the temperature is 30 degrees Celsius. This is 30 degrees Celsius. At this 30 degrees Celsius, what is the saturated pressure? The pressure in between the pH curve, saturated liquid and saturated vapor curve. This is the pressure. This is saturated pressure for 30 degrees Celsius. If we find out the volume at this point, this is the volume. We will vertically check out. This is the volume. This is the volume at 30 degrees Celsius for refrigerant R12. If I want to find out the enthalpy of liquid and enthalpy of vapor, this is enthalpy of liquid and this is the enthalpy of vapor at 30 degrees Celsius in saturated region. That's mean the 229.04 is the enthalpy of a liquid at 30 degrees Celsius in saturated region, and 365.31 is enthalpy of saturated vapor at 30 degrees Celsius. Similarly, I want to find out the entropy of the liquid and entropy of vapor at 30 degrees Celsius. This is the entropy of liquid at 30 degrees Celsius, 1.0997, and entropy of vapor at 30 degrees Celsius. This one is entropy of vapor at 30 degrees Celsius. So we will calculate all the parameters. If I got saturated pressure and saturated temperature, we find out the entropy, all the parameters of entropy, all the parameters of enthalpy, volumes, density, if we got the pressure and temperature both. So this is the refrigeration table which we are using, and after this there is a refrigeration R12. Similarly to oil, this is a critical point. This is saturated liquid line, this one is saturated vapor line, these are dryness fraction line, this is a constant temperature 0 degrees Celsius, 0 degrees Celsius, and again 0 degrees Celsius. These are entropy constant entropy lines. These are constant entropy line. This is constant pressure line. Point 1. There is a point 1. There is a point 1. This is the constant enthalpy line. 350 degrees Celsius to 350 degrees Celsius. Sorry, no, it's not a degree Celsius. 350 to 350 kilojoule per kg. The unit is kilojoule per kg. 500 to 500. There is 500. There is 500. These are the enthalpies. So after this, again there is a refrigeration table. The refrigeration table based on R22, refrigerant 22, the nomenclature of refrigerant 22. Similarly, if the saturated temperature is 40 degrees Celsius and the saturated pressure is 1.53, there is enthalpy of liquid 249, enthalpy of vapor 416, and entropy of liquid, this one is 1.16, and entropy of vapor, this one. So we will calculate the FHG, this is enthalpy of gas, HFG, which is equal to Hg minus Hf, this is the latent heat. Similarly SF and SFG, SF and SFG, SFG is Sg minus Sf. So through this we will calculate, this is Sg is this one value, entropy of vapor, Sf is this one value, entropy of SFG is difference of both. Similarly, this one is Hg, enthalpy of vapor, this one is F, enthalpy of fluid. The difference of these two gives FG. So this is useful in calculation work. So thank you guys, thank you very much for watching this video. Thank you.
वतन वतन मेरे आबाद रहे तू, है वतन वतन मेरे आबाद रहे तू, मैं जहाँ रहूँ जहाँ मैं याद रहे तू, मैं जहाँ रहूँ जहाँ मैं याद रहे तू, है वतन मेरे वतन.
Subscribe to our